Good morning, students. I hope you all are well and doing mathematics well. As you know that we are doing linear algebra, and linear algebra is the study of vector spaces. In the last video, we have tried to define the word vector space, but it was not completed. Partially we completed it. Today we will come to the remaining part of the definition of vector space. So let us continue. A vector space is a triple over the field F where V is a non-empty set are binary compositions as internal composition, and this is external composition. You people know that. A vector space is a triple. Today I have used a new word, triple. 3 members over the field F. We have already defined field. Okay, so a vector space is a triple over the field F where V is a non-empty set. This symbol and this symbol are binary compositions as this one as well as this one. This is addition and this is multiplication, but it is not ordinary multiplication. This is scalar multiplication. Okay, so a vector space is a triple over this are binary compositions as such that the following properties assumes hold. This was explained very well. All the things we have done in previous videos. So if you have any doubt in some particular term, then you just revise that. A vector space is a triple. That means a vector space is a non-empty set along with 2 binary compositions. One is internal, other is external. The internal means V cross V to V External means F cross V to V. This is addition and this is scalar multiplication. In the previous video, as you know that the elements of the set V are known as vectors, and here vector doesn't mean the vector quantity that we have learnt in vector algebra or in physics. Here the element may be the matrix, then matrix is treated as the vector. Okay, so it is like this, such that the following properties hold. Is an abelian group. This we have already discussed. This is an abelian group. That means 5 properties: closure property, associativity, commutativity, existence of identity elements, and for every element of V there exists the inverse. If we have these properties, then under this composition, this is known as abelian group. So in the last video we have done till this one. Now we come to the remaining part of this, that is the second one. Number 2. The first one is completed with respect to this composition. Now we come to this composition. As you know that this is filled elements are called scalars, or you can say numbers. Here it is, elements are called vectors. This is F cross V. So pair is formed. In that pair, first component, first member is a number and second member is a vector. Vector means element of the set V. Again I am telling you, vector does not mean the vector quantity. Here it may be matrix or it may be any other element also. For example, one member I consider from this, other I consider from this one. So it looks like this type of situation we will have in F cross V. That means input, because the binary composition is a function. So it looks like a device, that means a machine, that is input, output, input, output. What is the input? Input is this. Which type of input we have? One is number and other is a vector, and here vector is taken as matrix, for example. What is the rule? The multiplication. Which type of multiplication? Scalar multiplication. And you people know that if we multiply these two, then every element of the matrix will be multiplied by this. So the answer is minus 6, 3, minus 9 and 12. Again, this is a matrix and this belongs to V. That means here it is. This is known as external composition. So if we do this one, that means the closure property holds. So here the second part, I write the first one. For all A belongs to F alpha belongs to V implies A alpha belongs to V. What is A? Here it is minus 3. A means this. What is alpha? Alpha means this. This is A means this. Alpha means this one. For all operation is applied. What is the operation? Scalar multiplication. What is the result? Here this is the result. That means this one. And this must be the element of V. Here V is set of matrices of order 2 by 2 with real entries. Real entry means elements of the matrix be the real numbers here. Okay, so it is this type of situation. So what is the first property? For all A belongs to F, for all alpha belongs to V, we must have this type of situation. So this is closure. Okay, now we come to the second part. Number 2. For all A comma B belongs to F, alpha belongs to V implies A plus B alpha equals to A alpha plus B alpha. It looks so simple. ऐसा लग रहा है क्या किया है, मल्टीप्लाई तो किया है और ये तो हम बचपन से करते हुए आ रहे हैं, लेकिन नहीं, माइन्यूटली ऑब्जर्व करना है इसको, माइन्यूटली लिसन. A and B scalars, numbers, alpha vector. For example, I write one number that is 2 and other one, suppose I say minus 1 by 3. For examples, belongs to F. This is 1 minus 1 0 1 belongs to V. Look at this. Consider two members of this, one member of this. This implies this must hold. It is 2 alpha means C. A means 2 B means minus 1 by 3 and here it is 1 minus 0. Look at this. There are 4 types of symbol. V, and F. Note it carefully. This is internal composition, this is external composition. Internal composition defined on V, external composition it is also on V, but with the help of F. F is a field, addition and multiplication. This is addition of 2 numbers and this is the multiplication of 2 numbers. Here this plus sign. This plus means this one. Sum of scalars. Here it is this. This is alpha. Alpha. This is a number. This is a vector. So this is scalar multiplication. Scalar multiplication means here this holds. ध्यान रखना है, यहाँ सिंबल नहीं लिखा है, ये मल्टीप्लिकेशन है, लेकिन ये स्केलर मल्टीप्लिकेशन है और स्केलर मल्टीप्लिकेशन का सिंबल ये है, ये ऑर्डिनरी मल्टीप्लिकेशन है. सो बी केयरफुल. इट मीन्स दिस मस्ट बी रीरिटन एज scalar multiplication. So it is this is a vector quantity. This is also a vector quantity. When you multiply this by this, you will find a vector. You can say this. This is a vector. This is a vector. कंफ्यूज नहीं होना है. वेक्टर आपको लग रहा होगा कि दिखती तो मैट्रिक्स है और सर वेक्टर वेक्टर बोल रहे हैं. अरे भाई ये मैट्रिक्स तो है, लेकिन ये किसका मेंबर है? ये वी का मेंबर है और वी के मेंबर को हमने क्या नाम दिया है? वेक्टर. That's why I am telling this as vector. So this is vector. This is also vector. This is vector. This is also a vector. But what is this? This is sum of 2 vectors. In sum of 2 vectors, the symbol is used this. So here it is. This symbol. What is this? So here it is this symbol. कुछ आया समझ में? दोनों के बीच में मल्टीप्लिकेशन साइन, यहाँ जो साइन होगा मल्टीप्लिकेशन, दैट मीन्स इट इज दिस. Here it is this. Here it is this. Here it is this. Then this is the final answer. इसलिए ध्यान रखना है कि जो यहाँ पर प्लस लिखा हुआ है और जो यहाँ पर प्लस है, ये प्लस 2 स्केलर्स के बीच में है, 2 नंबर्स के बीच में है, और ये जो प्लस है वो 2 वेक्टर्स के बीच में है. जब 2 वेक्टर्स का सम एडिशन है, हमने उसके कंपोजिशन को इससे डिनोट किया है. मल्टीप्लिकेशन के कंपोजिशन को इससे डिनोट किया है, स्केलर मल्टीप्लिकेशन है और ये ऑर्डिनरी मल्टीप्लिकेशन है। यदि आपको ये कॉन्सेप्ट क्लियर हो तो आपको ये ध्यान होना चाहिए कि कहाँ पर स्केलर के लिए हम प्लस यूज़ कर रहे हैं और कहाँ पर मैट्रिक्स के लिए यूज़ कर रहे हैं। मैं बार बार इन सिंबल्स को रिपीट नहीं करूँगा, मैं दोनों जगह ऑर्डिनरी प्लस ही लगाऊंगा, लेकिन आपको समझना है कि कौन सा प्लस किस में काम कर रहा है। और मल्टीप्लिकेशन के लिए मैं डॉट यूज़ नहीं करूंगा, ये आपको ध्यान रखना है कि वहाँ पर कौन सा मल्टीप्लिकेशन यूज हो रहा है। सबसे बेस्ट ये है कि आपको ये देखना है कि नंबर्स ऐड हो रहे हैं या वेक्टर्स ऐड हो रहे हैं, नंबर्स मल्टीप्लाई हो रहे हैं या नंबर और वेक्टर मल्टीप्लाई हो रहा है। सो इट इज़ अप टू यू। ओके, सो लेट अस come to this. Two scalars, one vector. Situation is like this. Now you know that which type of symbol is to be used here. This is called distributive property. बंटन गुणधर्म हिंदी में बोलते हैं। बंटन गुणधर्म distribute over scalar addition just like this. Okay, now closure distributive, but here distributive with respect to addition of two scalars. Now we change the situation. Instead of these two we will consider vectors and this we will consider a number. So let us see number third. It is better to write this way. Okay, now I hope you can understand it easily. This is a number, means scalar. Vector, so sum of two vectors means here sum of two matrices is again a matrix. If this is matrix, here scalar multiplication. Scalar. So sign is not used, means here this one is used. This one. Here also sign is not used, but we know that this sign is used. Here this is used, and of course you know that here it will be this symbol, because this is vector quantity, this is vector quantity, so it is sum of two vectors. One thing more, this is not the ordinary plus. This is vector means matrix, this is vector means it is a matrix, so it is this one. Okay, इसलिए ध्यान रखना है कि कौन सा सिंबल कहाँ काम कर रहा है। मैं बार बार इस बात को रिपीट कर रहा हूँ। दो नंबर्स का सम हो, ऑर्डिनरी प्लस दो नंबर्स का मल्टीप्लिकेशन हो, डॉट वेक्टर्स का सम प्लस विथ सर्कल scalar means number and vector, then use dot over the circle. Okay, but we will use the ordinary plus and simply dot or not. It is up to you which symbol is there, which symbol exists. Okay, so this is the situation. Alpha and beta both belongs to V, so this composition is used. Here it is scalar, this is a vector. Here it is multiplication. Which type of multiplication? Scalar multiplication. So we will use this symbol. Ordinary multiplication. There is no ordinary multiplication because we are not using two numbers as multiplication. Here we are using two numbers but in addition, so ordinary addition. Okay. So you see in the similar way, you know that here this. And here it is this one. Okay, so try to understand. Fourth one, this is also distributive property. Distributive over scalars, distributive over matrices. Now the fourth one is associativity, but in different way. See, A is a number, B is a number. So multiplication of two numbers. Multiplication of two numbers means ordinary dot here. Simply this. Multiplication of two numbers is a number. So the final answer is a number, that is scalar. Alpha, this is a vector quantity. So a number is multiplied by vector. So it is scalar multiplication. So here the symbol is this one. समझ में आया? बचपन में हमने ऐसे ही बिना किसी चिंता के धाड़ 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 मल्टीप्लाई किया था, बिना सोचे समझे। अरे इसमें क्या है, बहुत आसान है। लेकिन यहाँ आपको बहुत डेप्थ में देखना है कि कौन किससे मल्टीप्लाई हो रहा है। जैसे आप मूवी देखते हो तो सस्पेंस मूवी होती है, उसमें कौन किससे किसका रिलेशन होता है, उसको देखने में बहुत ध्यान लगाना पड़ता है, बहुत ध्यान से देखना पड़ता है उसको। यहाँ पर भी बिल्कुल वैसा ही है। मैंने साइन यूज़ नहीं किया है, न मैंने डॉट यूज़ किया है, मैंने न डॉट के ऊपर सर्कल यूज़ किया है। आपको देखना है ये दो, ए नंबर है, बी भी नंबर है, दो नंबर्स का प्रोडक्ट है, इसलिए सिंपल डॉट। ये वेक्टर है, ये वेक्टर है और ये दो नंबर स्केलर मल्टीप्लिकेशन। यहाँ साइन जो यूज हो रहा है वो स्केलर मल्टीप्लिकेशन का होगा। अब जरा यहाँ जाओ, ए नंबर मीन्स स्केलर, ध्यान से देखना इसको। बी स्केलर, अल्फा वेक्टर, इसलिए scalar vector. So here the symbol is this one, scalar multiplication. This is a scalar and this complete one, when this is multiplied by this complete, the whole, this one is a vector. So this is a number, this is a vector. So here the symbol is C. Okay, so this is very important. Don't get confusion. Remember, as you remember in previous classes, you have to think about which type of situation is given. Two numbers, use this. Two vectors, use this. Two vectors. This one is used between a number and a vector because this is the external composition. Okay, so this is the fourth one. This is the associativity. Fifth. Again, you will see 1 into this is this one. But we remember 1 belongs to F. Here this 1 is unit element. Means multiplicative identity. Multiplicative identity. What is F? Filled. This is commutative with respect to this abelian group. This is also commutative group with respect to this. Means abelian group with respect to addition and abelian group with respect to multiplication. So this has two identities. One is additive identity, other is multiplicative identity. The name of additive identity is known as 0 and the name of multiplicative identity is known as unit element. तत्समक अवयव इकाई सदस्य वो यहाँ पर ये 1 है. So alpha is a vector, 1 is a number, so it is scalar multiplication. So the symbol is used. Okay, so let us see. Remember, this is abelian group with respect to this. This is abelian group with respect to this. Here, V is abelian with respect to addition only. It is not abelian with respect to this. नहीं हो सकता है, एक्सटर्नल कंपोजिशन है, इसलिए एक्सटर्नल होने की वजह से मुझे इन दोनों के कनेक्शन की बात करनी है. क्लोजर प्रॉपर्टी, it is that this one and this one closure property. You people know that. Then here you can say distributive with respect to scalar, with respect to vector, associativity, and this. So how many properties? This has 5 properties. 1, 2, 3, 4 and 5 properties. This also has 5 properties. Abelian group, 5 properties including closure property. Some authors do not consider the closure property because it is inbuilt in binary composition, but I consider. I just verify this one. It is okay. Someone is saying that it is that, but I have to verify yes or no. The statement is given. it is binary composition, but I have to verify either it is true or false, whatever it is. Okay, so V with two compositions, internal, external. V is non-empty set, F is also non-empty set. Now we compile this. So a vector space is a triple. This is triple. Pair means two members. Triple means three members. This is also triple. This is also triple. This is triple. But this triple is a field, and this triple is a vector space. So V is a vector space over the field F if it has properties. Which type of properties? We have discussed 10 properties. 5 with respect to this, and 5 with respect to this, and remaining 1. So if this satisfies all these properties, then V is called a vector space. Okay, so now we rewrite the definition in short form. A vector space is a triple over the field F if following is a commutative group. Second, fourth, fifth, commutative group means combination. Okay, so vector space is a triple over the field F. Sometimes we say V is called a vector space over F. V is called a vector space over F if we have this. V is called vector space over F is denoted by this symbol. V is a vector space over the field F. V is a vector space over the field F. So let us revise. If I say simply, let V is a vector space. Let V is a vector space. Saying this one, it looks so simple, but it has several things. Today is the 6th video, and to define a word vector space, I consumed a lot of time because I want that every basic concept must be used and revision is must. So if you have any doubt, any difficulty, you revise the videos again and again and write your comments in comment box. So today we have defined the word vector space. After that we will continue for this particular part of it. Thank you very much.